This is part 5 of the vector review. So here I'm showing you the resultant, which is designated by R, of the vector addition of vectors A, B, and D from page 3 of our physics classroom. Now, getting back to if we simply have two vectors, what we need to do is the following. We would see here that we have triangles and we can represent the direction of the resultant and also a vector equation and the resultant. So you're to label, considering the tip to tail method, which one of these A, B, or C is the vector resultant in each case. Now let's go back to taking notes. So let me show you the next portion of the notes that are the review for the test on Tuesday. I'll have these notes on Edmodo in a picture form in case it's hard to see this. So, notes continued. We discussed the vector resolution. There's several different methods for resolving vectors. The first one is a graphing method where you choose a scale. We did this. The worksheet was called Graphical Method of Vector Resolution, which you have in your notes. I allowed you to keep that. So the first thing is to choose a scale and then to draw the vectors using the tip to tail method. And you can see there I said that there's a YouTube video on Edmodo. So once we draw our vectors, here you can see we have A and B, then we could describe them by a Cartesian coordinate system. We could say A is +3, as you can see I went over 3 to the east, and then B is +2 in the x direction and -2 in the y direction. So we could measure the resultant and say, okay, given our scale, if 1 centimeter equals 1 meter, then I can measure my resultant and just express that in meters. Or another method of doing it, and this is a more exact method of doing it, is to calculate by having separated out our A and B vectors and express them or describe them in x and y coordinates. We have our A is +3x and our B is +2. So we could simply add those and say, okay, our resultant is 5 and the y direction was 0 for A and -2 for B. So that, if we add those two, is -2, and then we just describe that resultant, and that is describing, by the way, the direction and the magnitude of it. So we describe the vector, we say resultant R is 5, -2. Now, I'm not going to measure the vector because you're not assessed based on the measuring of it, but you will need to know how to use the XY method. Okay, a beautiful thing, which I hope you come to appreciate, is that we can not only describe it using X and Y, but that really relates to the Cartesian coordinate system, and that is to the compass rose description. So designating north, south, east, and west. Now, not everything travels perfectly in a northerly, southerly, easterly, or westerly direction. So we have to be more specific. Now, here on the side, I said, see the notes in previous worksheet because we have covered this. We have a worksheet that is called, as you can see, letter B here. The worksheet is called Measuring Angles with CCW from East. Well, that means counterclockwise from east. So we can say, all right, east is 0. We're always going to consider east to be 0, and then we're going to go in a counterclockwise direction, which you can see by the arrow. If we have a vector, which is drawn there, and then we have angle theta, which is the Greek letter which looks like an O with a horizontal line through it, then what we do is we simply measure by putting a protractor on the origin of that vector and measure it counterclockwise from east. So anything in quadrant 1 is going to be under 90 degrees. Anything in quadrant 2 is going to be up to 180. Anything in quadrant 3 is going to be up to 270, no greater than. And anything in quadrant 4 is going to be no greater than 360. So that is the 360 method of measuring angles. And you have the worksheet where we practice measuring all those angles. The next method is resolution of vectors using Pythagorean theorem. And so if you have two vectors, that's our resultant, that is going to make a triangle. So if we're going to resolve that, then we can use Pythagorean theorem based on a word problem. Go ahead and consider the word problem here. If we have a plane that's traveling north at 550 meters per second, which you see there's the arrow going north, and then it encounters a 10 meter east crosswind, and that should be meters per second, by the way. So I'll update that in the picture of the notes on Emoto. So then we ask ourselves, what's the resultant velocity? So the resultant velocity, we would say, okay, our resultant is shown there as the arrow that is pointing in the northeast direction. So a resultant, if we want to get the magnitude of that, then we can say it is just c squared, whereas a squared plus b squared equals c squared, and we just take the square root of the velocity, which is 550 squared, plus 10 squared, which is the crosswind, and we get, if we use significant figures, we actually get the same answer, which is 550. It doesn't really significantly affect the velocity having that much of a crosswind. But we do use Pythagorean theorem, and we can say if we measured the angle, we could have this be a vector quantity, because 550 meters per second, that would be our speed. In order for it to be a vector, it would have to have a direction, which we would measure the angle using the counterclockwise from east method.